Today, we are going to be talking about systems of equations. A system of equations is a set of equations joined by the words and. Together, they describe the same situation. A solution to a system is an ordered pair that makes each equation true. So with a system of equations, you have two equations. They describe the exact same situation, and the solution is a coordinate point that makes both of them true. So when you plug in the x and the y into the equations, you will get two true equations. The first thing we are going to do is to test a coordinate point. So we have our systems of equations here. Y equals 3x minus 4 and y equals negative 1/2 x plus 3. We are going to test the coordinate point for 1. So the first thing we are going to do is choose one equation. I always choose the one on the top, and every time we see an x, we are going to plug in a 4, and every time we see a y, we are going to plug in a 1. So I am going to simplify this by doing the math and simplifying it completely till I have no more math symbols, and as you can see, when I simplified it, I got 1 equals 12 minus 4, which equals 1 equals 8, which is not true, which means that 4, 1 is not a solution to this equation. So we can stop testing. We do not need to test the other coordinate or the other equation. So we are going to use the same two equations that we used last time, only this time we are going to test coordinate point 2, 2. So once again, every time I see an x and a y, I'm going to plug in a 2 and a 2, and then I am going to simplify it. As you can see on the first equation, once simplified, you get 2 equals 2, which makes a true equation. So we are going to go on and test our next equation. So once again, we are plugging in our coordinate points 2, 2, and because I have a fraction, I am plugging in the x in as a 2 and changing it to fraction form before multiplying it. I will then simplify the fraction I get when I multiply it. I get 2 equals negative 1 plus 3. When I simplify that, I get 2 equals 2, which again is a true statement. So 2, 2 is a solution to this system of equations because it made each equation true when plugged in. Next, we're going to look at one way to solve for a system of equations if you're not given a coordinate point to test. To do this, we are going to make a table. So we're going to make a double table with an x column, and because I have a fraction in there, I'm going to look at my denominators and use multiples of my denominators to make my table. Next, I am going to go row by row by plugging in the value and solving. So I did y equals negative 1/2 times 0 minus 2 and got negative 2, and then doing y equals negative 3/2 x or 0 plus 2, which equals 2. And then I continued that with an x value of 2, and I got negative 3 and negative 1. And I'm looking for my y values to be the same to know that it is a solution. So since negative 3 and negative 1 are not the same, I'm going to continue. Next, I plugged in 4, and when I plugged in 4, both equations turned out to equal negative 4, and since both my y values are negative 4, I can stop because that is the solution because y equaled the same thing. You can also do this on a graph or on your graphing calculator. So you would make a table, plot the points, and then you are looking for where the two lines you graphed intersected or where they meet. You would type in both equations on your graphing calculator under y1 and y2, and then hit graph and watch the lines draw on your calculator and look for where they cross. You could also use the table function on your graphing calculator to look for where the y's are the same instead of making your own table.